Good morning, class. I am teacher Christine and I'll be your science teacher for the whole year. Okay, let's start this day with a prayer. I'll be calling Angel to lead us our prayer. Okay, thank you so much, Angel, for leading the prayer. Okay, I'll be calling your names. If you are present, please raise your hand and say present, Miss. Okay. Okay, I can see that all of us are present, so we're going to proceed to our main discussion or topic for today. But I can see some of you are a little sleepy. So we will going to have a little energizer and I'll be calling one of our active dancer. Anjo, please lead our energizer. Okay, thank you, Anjo, for leading as our energizer. We are all engaged and activated. And I guess we will be very activated throughout our discussion for today. So before we're going to have our discussion for today, we're going to review some important knowledge that we'll be using throughout this discussion. So the title of our review or activity for the review is which is which. So you are going to categorize phrases according to if it is force and if it is motion. Okay, so I guess, and I can see with the results that all of you are knowledgeable enough about force and motion, and I guess that you will not have difficulty in understanding our lesson for today. Good morning once again. Our first activity for this morning is entitled the mystery box. So all you need to do is you are going to pick a picture inside the box and then you will going to share your thoughts to your classmates on what you think the picture is all about. I'll be calling 6 students to participate in this activity. Hey, Sheena. Okay, Sheena is right. The picture F is all about a man in the office. And this man is working. Another, may I call on Toniel. Okay, Toniel is right. The picture C is all about a man lifting vegetables. Another, how about Lynette? Okay, thank you, Lynette, for your thoughts. So Lynette is right. The picture E is all about a man lifting a tray, or this man is a waiter. Okay, another. How about Courtney? Okay, thank you, Courtney, for your thoughts. So that was amazing. So Courtney is right. The picture A is all about a man pushing a cart. Okay, another. How about May? Okay, May is right. The picture B is all about a woman lifting a barbell or a woman in the gym. For the last, may I call in Crystal, please? Okay, thank you, Crystal, for sharing your thoughts. And Crystal is right. The picture D is all about the man in the carpentry or man lifting woods. Thank you so much for participating in this activity. So in general, what do you think these pictures is all about? Okay, please, Emmy. Okay, thank you, Emmy. And Emmy is right that these pictures is all about the man and the woman in different fields. Personally, which of these following pictures will you most likely do every day? Okay, Marie. Okay, Marie wanted to be like the picture B. She wanted to be in the gym. Okay, how about Joseph? Okay, thank you, Joseph. So Joseph wanted to be like the picture E. He wanted to work in the restaurant. Okay, last, how about Alex? Okay, thank you, Alex, for your thoughts and sharing. So Alex wanted to be like in the picture F. So he wanted to work in the office. Okay, thank you so much. Some of you wanted to be in the office dealing with paperwork, and some of you wanted to be in the gym working out and exercising, and some of you wanted to be in the restaurant serving customers. So what do you call these actions, Joseph? Okay, Joseph is right that this action is all about work. So our topic for today is about work. At the end of this lesson, you are expected to define work, identify and explain situations in which work is done and in which no work is done. And then you are also expected to demonstrate real life scenarios where work is evident. And last but not the least, you are expected to solve problems related to work. So for us to have a little insights about the main concept of this topic, work, so we will going to have an activity. So this activity is entitled Act It Out. So I'll be grouping you into 5. Row 1 will be group 1. Row 2 will be group 2. Row 3 will be group 3. Row 4 will be group 4. And row 5 will be a group 5. So all you need to do is you will going to select a member in your group to be the representative to demonstrate the given scenarios, and the rest of the members will going to identify which of the demonstration or which of the scenario belongs to the category work is done and no work is done. So after you are done with the activity, you are going to select a representative to share your work to the class. You will be given 10 minutes to do the activity. Thank you so much for sharing. I can say that you have an idea about our discussion for today. So we will be categorizing these according to your sharing. So picture F, the man in the office, belongs to no work is done. How about picture A, man pushing a cart? So picture A belongs to work is done. How about picture B, a woman lifting a barbell? This belongs to work is done. How about the man lifting vegetables? Okay, this belongs to no work is done. How about picture E, a man lifting a tray? So this belongs to no work is done. You're right. How about picture D, man or carpenters lifting woods? Okay, you're right. So this belongs also to no work is done. So 4 pictures belongs to no work is done and 2 pictures belongs to work is done. And I can see that some of you are wrong, but it's okay because we will going to learn as we go along in this lesson. So according to how we categorize it, what made you say that these pictures A and B belongs to work is done? Josephine. Okay, Josephine is telling us that these pictures belongs to work is done because the force exerted to the object makes a displacement in the same direction with the force. So how about these pictures? What made you say that these belongs to no work is done? May. Okay, thank you, May. So May is telling us that these pictures belongs to no work is done because the force exerted on the object makes a displacement but in a different direction with the force. So we will going to check those concepts and ideas as we go along with our discussion for today. Okay, what is work? Sam. Okay, thank you, Sam, for your idea. How about Miguel? Okay, thank you, Miguel, for your idea. So what is work? So work, it is a measure of energy transfer that occurs when an object is moved over a distance by an external force. Remember that, external force, at least part of which is applied in the direction of the displacement. So remember, force and displacement, because these concepts or these words will be very important as we go along in this topic. Okay, so what made you say that work is done? So we are going to check if you are correct earlier. So work is done when the force applied to the object causes the object to have displacement in the same direction as the force applied. So Joseph is right earlier that these pictures belongs to work is done because the force exerted by the people or the person in the object causes a displacement in the same direction. Okay, one example of this is the man pushing a cart. So what made us say that work is done in here? So work is done because the man is exerting a force in sideward direction and he is also moving in motion in a sideward direction. So the force exerted is the same direction with the displacement. So that made us say that work is done. So how about the woman lifting the barbell? So the woman lifting the barbell belongs to work is done because the woman is lifting the barbell the force exerted by the woman to the barbell is in upward direction, and the barbell is racing also in an upward direction. So the force applied is in the same direction with the displacement of the barbell. Okay, so how about no work is done? So no work is done when the force applied to the object causes the object to have a displacement in the different direction with the force applied. So we are correct earlier. So let's take, for example, here, picture letter E. So the man carrying a tray. So the man carrying a tray is exerting a force in an upward direction, but the motion of the man walking is in solidward direction. So the force is not in the same direction with the displacement. So it is different because upward, the force is upward, but the motion is sideward. So another is no work is done when the force applied to the object does not cause the object to have a displacement. So let's take, for example, here is letter F. So the man is just exerting a force, but there is no displacement. Another specific example of no work is done is pushing a wall. So in pushing a wall, you are exerting so much effort, but the wall is not moving. So there is no work done in that. So how can we calculate work? So we will be using the equation work, which is in joules, is equals to applied force in Newton times distance in meters. So the formula would be W, which is work, equals force times distance. I have here two sample problems that will give us idea on how to apply the equation or the formula of work in a given problem. Okay, so sample problem number 1. Suppose a man is pushing a cart with a 600 Newton force along the 10-meter aisle. How much work is done in pushing the cart from the one end of the aisle to the other? So we have learned in the previous year that in solving a problem, we will be following the format or the process GAFSA. So what is GAFSA? So first is the given. So we will going to identify the given. So what is given here? The force, which is 600 Newton, and then the distance, which is 10 meter. So GAFSA, next is A. So what is asked? So what is asked here is the work. Next is the formula to be used. What will be the formula to be used? So we will going to use the formula work is equals to force times distance. So next will be the solution. So we will going to proceed by using the formula. So the work is equals to force times distance. So what is the value of force? 600 Newton times the distance of 10 meter. So 600 Newton times 10 meter is equals to 6,000 Newton meter or 6,000 joules. So our next sample problem is a balikbayan box of mass of 30 kilogram is on the floor. If the box is lifted from the floor to the top of the table, which is 2 meters from the floor, how much work is done on the box? So we will going to follow the same process that we did in the sample problem number 1. So GAFSA. So first is the given. So what is the given here? So the given is mass, which is 30 kilogram. So next is the distance, which is 2 meter. 2 meter. Okay, so next is what is asked here. So what is asked is work. So the formula to be used is work is equals to force times distance. So here we can observe that force is not given but the mass. But we know in our previous years or previous topic that we can get force by mass times acceleration due to gravity. So we'll be multiplying it by distance. So now that we know how to get the force, so we can now solve the problem. So mass is equals to 30 kilogram. So how much is the acceleration due to gravity? What is the value of it? So the value of acceleration due to gravity is 9.8 meter per second. So the distance is 2 meters. So we're going to multiply it. So work is equals to 30 times 9.8. Okay, so what is 30 times 9.8? So we will going to calculate it. So 30 times 9.8 equals 294. 294 kilogram meter per second times 2 meters. So we're going to multiply it times 2 meters is equals to 588. So Newton meter, because we know that kilogram meter per second is Newton. So we will going to proceed with work is equals to 588 and joules. Okay, so in this moment, we will going to apply your learnings about work in different areas. So do the reminiscing thy past activity. So all you need to do is you will going to list down all your favorite activities you did in the past and classify these actions into no work is done and work is done in a one whole sheet of paper. Do this in 5 minutes only. Okay, now that you're done answering the activity, I'll be call 3 students to share their activity to the class. I'll be calling Shane, Jason, and Alex. Okay, thank you so much for sharing your past to the class. Okay, now that your 3 classmates are done sharing, so pass now your papers because I'll be checking it and I will return it tomorrow. Okay, let's check if you have learned something today. So answer the 10-item quiz in a 1/2 sheet of clean paper. Finish this within 15 minutes only. Okay, so for your assignment, answer the question, why do living beings and machine needs energy in a 200-word essay? So these will be submitted on Wednesday and this will be graded according to the content and development, the organization and structure, the sentence structure, grammar, mechanics, and spelling, and also neatness and completeness. So your essay must include 200 words and above, not below 200. Okay, so that would be all for today. Let's call it a day, class, and goodbye.